You hear me okay without echo?
Yeah.
Okay, good.
Okay.
I will try to remember that you are Ethan.
Yeah.
Last
I'm
time,
Ethan.
last time we had a session, I did the whole entire session thinking you were Dylan the whole time.
Yeah.
That was funny. Um,
Yeah.
so, what kind of math are you taking, Ethan?
Well, I'm doing like, 1 second. What's that worksheet? I'm doing, making like, cents of percent and like, that's what it says on here.
Okay.
She's, taking a
Yeah.
picture of it and she's gonna email it to you, the
Okay.
problem, so.
That'll work. I can certainly open up my
Cool.
email. Are there some problems that maybe you could verbalize that we could get started on?
Yeah, I'll read you the problem right now.
Yeah, I'll read you the problem right now.
Okay.
Let's see.
I'm going to turn my camera off.
Hey, Mike. You just read in the problem. During a recent year.
Wait, Mom, I have to find that worksheet. 1 second.
All right.
Where is that? Here it is. I have to get that out. Okay. So the problem is, go to the page real fast. It says, during a recent year, Yao Ming made 301 out of 371 free throw attempts, and Shaquille O'Neal made 451 out of 75 attempts.
I don't think so. He didn't make 451 out of 75 attempts. That's impossible.
Oh, it says during a recent year, Yao Ming made 301 out of 371 free throw attempts.
Okay, that makes sense.
And yeah, and then Shaquille O'Neal made 451 out of 725 attempts.
725. That makes more sense.
Yeah.
Besides that, I remember Shaquille O'Neal, and he was a terrible free throw shooter. So
Yeah.
that makes more sense because anybody that doesn't shoot at like 80% is not a very good free throw shooter. So
Yeah.
what is it asking?
It's asking. Well, I did 1, 2, and 3. There's A, and then there's 1, 2, and 3.
Uh-huh.
And I did A1, A2, and A3. And then on A4, I have a question. So it says, so it shows a chart, and it's like a rectangular chart with 2 rectangles, and it's like really long, but it's like it says Yao Ming, and then so.
Tell me what A, B, and C asked you.
Well, 1, 2, and 3. It said, describe one way that and it says Will said that he drew some pictures to help him think about the percent of free throws made by Yao Ming and Shaquille O'Neal.
Okay.
And it said, but then he got stuck.
Well, what is this percentage here? 301 divided by 371.
It says 301 out of 371. What's your email? My mom's wondering. So you could email the worksheet. So.
I'll write it right here.
Okay. There it is, right there.
Thank you.
Okay.
All right. Thank you.
So what percentage did Yao Ming shoot at?
The Yao Ming, it doesn't say. So.
Well, what is 301 divided by 371? Do you have a calculator?
I do not. Could you go get a calculator? Or actually, I think my mom has it on her phone. So. Yeah, she has a calculator.
See if you can zoom in. I just emailed the worksheet to him.
Okay.
See if you can zoom in. Do you need a calculator?
Okay, let me look at my email and see if I got it yet.
Okay.
Haven't gotten it yet.
Okay.
Did it work?
Did it work?
I haven't gotten the email yet.
Okay. He hasn't gotten the email yet.
Okay.
And you sent it to David Cowan, 1949 at gmail.com.
Did you send it to that?
Yeah, let me send it again.
Yeah. She'll try sending it again, I guess. So.
Okay. Ah, something just came into my phone. I got it now.
It just came.
Okay.
She got it now. Okay.
See if he can zoom in on it. And you
See if you can zoom in on it.
Yeah. Let me download it first, and then open it up.
Okay.
I know, it's impossible to read. Sorry, can you zoom?
No, I can read it. It's fine.
Okay. And then the problem is on the top,
Yeah,
that's just
let me read it.
okay.
Okay, so what do we need to do?
Thank you.
Thank you. I know. I gotta charge my phone. No. Well, it does, but I just want to charge my phone. Okay. All right. So we'll be quiet. Okay, so what do you need?
So you've answered 1, 2, and 3.
Yeah.
I'm looking at 4.
Okay.
Where would the 50% mark be for Yao?
The 50% mark for Yao would be at the very center of the
Which is what number?
185.
So had he made 185, he would have shot at 50%. So he shot a lot better than that. He did 301. What's the 50% mark for Shaq?
It would be 362.
Well, he did better than that, but not a lot better. 451. So, to be honest with you here, I'm not sure what they're looking for. Estimate the number. So we did 3. For each player, estimate the position for the mark representing the number of free throws made. I think what they're asking for is what is the percentage that each player made.
Oh, okay.
So what did Yao make? What is 301 divided by 371?
Let me do that right now. So I got 1.2325581.
Okay, do it again. It's 301 divided by 371.
0.8113207.
And what about Shaq?
For Shaq, it would be 451 divided by 725. I got 0.622.
That sounds more like Shaq's free throw percentage.
Yeah.
So, who's the better free throw shooter?
Yes.
Yeah, Yao,
no.
Yao by a lot.
Yeah, Yao. Yao by a lot.
Yao by a lot. Okay. So, I'm not sure what they're looking for with this last sentence. Use a benchmark fraction to describe this location. Let's look at number B.
Okay. That's what I'm on, so.
Okay. Who has the better record, Yao or Shaq?
Yao.
Yeah, even though Shaq made more free throws, Yao had
Yao
a higher
has a better record.
percentage. And it's the
Yeah.
percentage that really matters. I mean, if
Mhm.
if you had to bet your life on who would make a free throw, you would go with Yao. You wouldn't go with Shaq, right?
Mhm.
So
Yeah.
the fact that he made 451 versus 301 is not the important information. The important information is the shooting percentage.
Yeah.
Yao's is much better than Shaq's.
Yeah. Okay.
So
So.
B, no is the answer. You do not agree. Shaq
Mhm.
does not have the better record.
Yeah, that's what I said. I said, I don't. The amount of free throws that both of them could shoot are different. Therefore, you would have to subtract 371 minus 301 and 725 minus 451. The answers are 70 and 274.
Right. But even that won't really
Yeah.
give you the right answer. The
No.
only thing that gives you the right answer is their percentage, that
Mhm.
versus that. In other
Yeah.
words, even though Shaq missed more, a lot
Yeah.
more, than Yao, what if Shaq
Mhm.
did 100 over 2? Well, let's say 50 over 100.
Mhm.
Let's pretend that Shaq shot 50 out of 100. Well,
Mhm.
he would have only missed 50 shots, and Yao
Yeah.
would have missed 70 shots, but that's not the measure. The measure
No.
of skill is the percentage success rate,
Mhm.
and that's the only thing that matters.
Yeah.
Although I've been a baseball fan for years,
Yeah.
one of my pet peeves is that they don't really keep the statistics right. They
Yeah.
Are you a baseball fan at all, Ethan?
Well, my brother is a huge one.
I know Dylan is, yeah. But
Yeah.
one of the
But yeah, I'm a baseball fan. So.
one of the stats they keep is batting average.
Yeah.
Okay? Well, batting average is hits per at bats.
Mhm.
So if you have 300 hits per 1,000 at bats, you're going to have a batting average of .333. And that is a
Mhm.
fair measure of the ability of a hitter.
Yeah.
On the other hand, the way they keep home run stats is by absolute number. In other words, if
Mhm.
somebody hits 52 home runs, they're probably going to win the home run title.
Yeah.
Well, my pet peeve has always been that it's not the absolute number of home runs that you hit that should be important. It's your
Mhm.
home run average. It should be
Yeah.
home runs per at bat.
Mhm.
And so for years, baseball has been keeping the wrong stats. In other words,
Mhm.
when they started 150 years ago, they started with batting average and they started with absolute number of home runs, and it's never been changed. So
Mhm.
baseball really does not keep the proper stats that they should. There should be a home run average. There should be a number
Mhm.
of home runs per at bat. That's what's important. In the same way that
Okay.
free throws, it's not important how many they made or how many they missed. What's
Mhm.
important is the percentage made.
Mhm.
All right.
Okay. I don't really understand how you got 85% for Yao.
Okay. Let's go work through the math on that. If we divide
Okay.
that on your calculator, divide 301 by 371.
Okay.
You get
I
point,
got, yeah,
point.
0.8113.
Okay. To convert this decimal to a percent, we need to move the decimal 2 spots to the right. So what
Mhm.
this is worth, that's 81.13%.
Oh, okay.
100% being perfect. If Yao would have made 371 free throws out of 371 attempts, he would be shooting at 100%. Nobody ever does that, but
No.
100% is the best you can do.
Yeah. Okay.
So what's Shaq's percentage free throw shooting? We know he made .622 of the number of free throws he took, but what percentage does that convert to?
Oh, let me do the math. 7.
There's really no math to do. All you have to do is move the decimal point 2 spots.
Yeah, 2 spots. So it'd be 62.2%.
That's as easy as it gets. There's nothing easier in math than converting decimals to percents. That's as easy as it gets. You move the decimal point 2 spots to the right. If you're converting from percents to decimal, you move it 2 spots to the left.
Okay. All right. So, alrighty. So I have for homework tonight. That was classwork today for homework.
Okay.
You get the page out.
All right.
I have. Let me get to it. Page 61. Let me get to it. Let's see. Okay. So it's pretty much the same thing that they're doing right now, but it says, in a recent year, Karl Malone made
That's
474.
KR. He hasn't played for a long time. He's been retired for about 10 years. Okay?
Yeah. Made 474 out of 621 free throw attempts.
Now
Then it says,
notice that I always divide. I always put the successes divided by the total.
Yeah.
That's the way you figure out percentage of
yeah. So 621 divided by 474?
Well, say that the other way. 474 divided by 621.
Okay.
And it makes a difference. In other words, you come up with a number less than 1 here. If you do it the other way around, you come up with a number greater than 1.
Yeah. Okay. So, and then it also says, and John Stockton made 237 out of 287 free throw attempts.
I'm sorry, what was those numbers?
237 out of 287 free throw attempts.
Okay.
Okay, and then it shows a bar, like the same bar like those on there. Then let me just get that page out real fast. Okay.
Put a bar. And here is 0%, and over here is 100%.
Yeah.
So what is Karl Malone's percent?
Karl Malone's percent is 621 at the very end.
Well, what decimal do you get when you divide 474 by 621? What is that decimal?
Divided by 621. 0.763.
What percentage is that?
76.3%.
So if I were plotting that, that would be about 3/4 of the way.
Yeah. Let me just...
And how about John Stockton? What is 237 divided by 287?
237 divided by 287. 0.825.
Which is what percent?
That is 82.5%.
Which falls right about there.
Mm-hmm.
Okay, now what do they want to know?
They want to know, it says copy the percent bars and use them to answer each question.
Okay.
Okay, and then, so I'll copy down everything. So, equals 76.3%. Okay, and then 237 to 87 equals 82.5.
And again, the only thing that really matters is that percent. In other words,
Yeah.
it doesn't matter that Carl made 474 versus John Stockton's 237. He is not the better free throw shooter.
No.
He shoots free throws at 76%. Stockton shoots them at 82.5%.
Mm-hmm.
Somebody came to you and said, which one would you like to have shooting a free throw for your life? You'd go with John Stockton.
Yeah.
All right.
He has 82.5%.
Right.
Okay. 76.3% and 82.5%. All right. And then, yeah, so that's pretty much, and then it says, what fraction benchmark is near the fraction of free throws made by each player?
Well, I'm not quite sure what they're asking there.
Yeah.
80% would be close,
Mm-hmm. And then,
but so would 75%. I mean, I don't know what they're really wanting there.
yeah.
80% is really close to Stockton, and it's pretty close to Malone also.
Mm-hmm.
But I really don't know what they're looking for. I don't know how to translate that into math.
Yeah, me neither.
It's not, well, I shouldn't say it's not important. The important thing you know here is that Malone shoots at 76.3, Stockton shoots at 82.5. That makes him the better free throw shooter.
Yeah.
What if somebody came along and made 9 out of 10?
That would be 90%.
Who would be the better free throw shooter? This guy? Let's say it's me, Dave Cowan.
Mm-hmm.
Who would be the better free throw shooter? Me, John Stockton, or Karl Malone?
You.
Maybe. And the reason I say maybe is because I don't really have a big enough sample. 10 free throws is enough to really compare my percentage with John Stockton's. He's taken 287 free throws. Maybe I just got lucky on my 10 free throws. You know what I mean?
Yeah.
In other words, if I was betting between me and John Stockton, I would tend to bet John Stockton because his is based on a very large sample size.
Mm-hmm.
Mine is based on a very small sample size. Anything can happen. In other words, what if I went 2 for 2? If I made 2 free throws attempts and I made 2 of them, well, that's 100%, but no way could I say that I'm a better free throw shooter than John Stockton. So,
yeah, because John Stockton made more free throws.
Well, it's not that. It's not really that. It's not the absolute number made because Karl Malone made the most. He made 474. So the percentage is very important, but the sample size is very important. This is the sample size. I only made 2 free throw attempts. So just because I made both of them does not make me a brilliant free throw shooter. And if you learn anything out of this, that's the thing you should learn, is that I don't know how to explain it. If you went to a Nuggets game and made a free throw from mid-court for a big prize, would that mean that you could make all free throws from mid-court? No, it wouldn't.
No.
Just means you got very fortunate on the one free throw that you made from mid-court. So the point of this, the mathematics of this, is to always look at the percent success. But it's also very important to know that you have to have a large enough sample. Karl Malone had 621 free throw attempts. So that's pretty, that's a lot. His free throw, in other words, it's pretty safe for me to assume that that's pretty close to his lifetime average. He played for 15 seasons, and I'd be willing to bet that he shot very close to 76% for his lifetime. And I happen to know that John Stockton was one of the better free throw shooters in basketball, and 82.5% is a pretty good percent for free throw shooting, so that's probably real close to his lifetime also. So maybe if I come in, I'm a brand new rookie, and I make my first 2 out of 2, it makes it look like I'm a superstar because it's 100%, but everybody knows that it's not really a number that we can put a lot of stock in. If I were to shoot 100 free throws, you would not expect me to make 100 of them.
Yeah.
Just because there's not enough sample size.
Yeah. Okay, so do you know what it means by fraction benchmark?
You know, I don't. I'm not sure what they're referring to there. I would say that the fractional benchmark would be the average free throw shooting percentage in the NBA, which if I had to guess, I would guess it would be close to that.
Yeah.
But I don't know. In other words, if you took every player in the NBA and calculated all their free throw attempts, let's say that they made 10,000 free throw attempts, and all of them combined made 7,500 of them, that would be a 75% average. And that's pretty close. It's somewhere between 75 and 80%. I used to be a huge basketball fan, not so much anymore, so I don't know what it is. But usually when somebody uses the word benchmark, they mean average of everybody. A benchmark batting average in the Major League Baseball would be that.
All right.
If you can hit over 300, you're going to make millions of dollars a year.
Yeah.
If you hit under 200, you're not going to last for more than one season in Major League Baseball.
Yeah.
So, and if you were to say, well, what's the benchmark average in baseball? Maybe I would say 240. In other words, if you hit over 240, you're probably going to stay in baseball. If you hit less than 240, it's going to be hard to make a career out of it. So that's the only thing I can imagine that they mean by benchmark. It's probably something they used in your class. I'm just not familiar with what they're referring to.
Yeah. So I'll put the average number of free throws for Malone is 75%. And 80% for Stockton.
Well, it's actually 76.3% for Malone.
Yeah.
and 82.5% for Stockton.
Okay.
And that's all you can really say. I mean, from the information they gave us, we don't know what the NBA average is.
Yeah.
They didn't tell us. If we had to figure out a benchmark, maybe what they mean is if we had to figure out a benchmark between these two players, well, what did they make? They made a total of 711 free throws out of 908 attempts. So together they did that.
Yeah.
So what is that number?
That would be, I'll divide it. 711 divided by 908. 0.783.
Okay. So if somebody says, what's the benchmark? And the only information they've given me is Carl and John's numbers, then I'm going to say the benchmark is 78.3. I'm going to take their combined free throws made and divide it by their combined free throw attempts.
Okay.
But a benchmark would really be more likely if you added every player in the NBA up. That would be the true benchmark. Taking a benchmark just between Carl and John, well, that's just two players. He was not a particularly good free throw shooter, and he was a very good free throw shooter. And together they average. Notice that this average is not halfway between this number and this number. Because Karl Malone took a lot more free throws. So when you total up the total free throw attempts and the total free throw successes, it comes out to be 78.3%, whereas if you average 76 and 82, you get more like 79%. So the benchmark actually is less than the average of those two numbers.
Okay, so it's asking what fraction benchmark is near the fraction of free throws made by each player.
Okay.
Let's use
78.3. So if I use 78.3, it's actually closer to Karl Malone than it is John Stockton.
Okay, so
notice that it's only 2 percentage points away from Karl Malone.
Yeah.
Exactly 2 percentage points. Well, it's 4.2 percentage points away from John Stockton. So the benchmark, assuming that's what they mean by the word benchmark, is closer to Karl Malone than it is John Stockton.
Yeah.
Why is that? Because he took far more attempts. He took more than twice as many attempts. So his average is going to weight more heavily than John Stockton's.
Okay, so I put the average number of free throws is 76.3% for Malone and 82.5 for Stockton. 78.3 would be near 76.3.
Okay.
And
Good.
80.
You might want to give an explanation as to how you came up with 78.3.
Yeah.
Make sure that on your explanation you added their total free throws made, which was 711, divided by their total free throws attempted, which was 908.
Okay.
And that's how you got 78.3.
Okay, so the total average, or the total free throw attempts is 711.
No, that's the total free throws made.
Oh, yeah. Free throws
Made. And you're going to divide that by the total free throw attempts.
Oh, okay. made a 7-Eleven, and you would divide it by 908.
Yeah. Now, notice what happens if I add my own free throws into that. My 2 for 2.
Okay.
It's not going to affect things that much. In other words, now it's 713. I'm going to add 2 free throws to the ones made. By 910, what's that number equal to?
713 divided by 910. It'd be 0.783. So
Notice that
78.3%.
it hardly changes it.
Yeah.
Why is that? Because I only made 2 free throws. I didn't have very much sample size. So I'm not going to affect the benchmark very much at all. In fact, I didn't even move it at all, making 2 for 2. Benchmark is still 78.3. Now, if you figured out the decimals after the 3, this number is going to be a little higher than this number. But when you round it to the tenths, it's the same number even. So this kind of shows you, I think what they're trying to get across is that the fact that I made 100% of my free throws doesn't really change the benchmark very much because it was only based on 2 free throws.
Yeah.
If I made 200 attempts and made all 200 of them, that number is going to go up a lot more. The benchmark would go up more.
Yeah.
Because that fraction would be a much higher fraction. So it's kind of a way, when you look at the benchmark, it's kind of a way of weighting the number of free throw attempts made.
Okay. And then for B, it's asking estimate the percent of free throws made by each player.
Well, we already did that.
Yeah.
Karl Malone was 76.3. John Stockton was 82.5.
Okay.
Wasn't an estimate. It was an exact figure. So I don't know why they said estimate. John Stockton.
Well, I think, are they wanting you to round it, maybe?
I don't think so. You can say categorically that John Stockton made 82.5% of his free throw attempts. And you can say that Karl Malone made 76.3% of his free throw attempts. And you can say that combined, they made 78.3% of their free throw attempts. That's the only important information there is. There's nothing else important about this situation. I mean, I'm not sure what all these things they're asking, but that's the only significant, relevant information that's worth knowing based on these 2 players.
Well, all right, so I put categorically Malone made 76.3% of his free throws. 80 Stockton made 82.5%.
Right.
82.5% of his free throws.
Right. And you might add that together, combined, they made 78.3% of their free throw attempts. If you were to take the 2 of them together.
Okay.
And that's all you can say is those 3 percentages.
Okay. Free throw attempts.
So you know who the greatest home run hitter in all time was?
Who? Babe Ruth, right?
No, you might think it was Babe Ruth. Babe Ruth hit 1 home run per 9 at-bats. Well,
Okay.
guess what? Mark McGwire, who's not nearly as well known, hit 1 home run per every 8.8 at-bats. That's a better rate. He's hitting a home run more frequently than Babe Ruth did.
Oh, so he's like the all-time hitter?
Well, it depends. Most baseball looks at the absolute number. Babe Ruth hit 751 home runs, which was actually exceeded by Hank Aaron. I think Hank Aaron hit like 757. But baseball doesn't pay attention to averages on home runs. So Mark McGwire's rate, which would say to you and say to me that he should be the greatest home run hitter in baseball history, he is not considered that. Babe Ruth is, because Babe Ruth hit the most absolute number.
Yeah.
This is why I'm saying that baseball is a little bit schizophrenic when it comes to keeping their stats. On one hand, they keep track of hits on an average basis, but on the other hand, they keep track of home runs on an absolute number of home runs hit.
Yeah.
Doesn't make sense. The thing that makes sense is Mark McGwire's. He is a prolific home run hitter. If he hit 1 home run for every 8.8 at-bats, he's a better home run hitter than Babe Ruth as far as I'm concerned.
Yeah.
Even though his total was only like 630 instead of 750. Was still a better home run hitter to me.
All right. So, how did you get 78.3 again?
78.3?
Yeah.
They took their total successful free throws, which was 474 plus 237,
Okay.
and divided by their total free throw attempts, which was 621 plus 287.
Oh, okay.
Which was 711 divided by 908, which gave me 78.3%.
Oh, now I get it. Equals 78.
That's probably what they mean by benchmark. I don't know what else they could mean, because they didn't really give us any other data. They didn't give us what the entire National Basketball Association shot. They just gave us 2.
Yeah.
So if you have to calculate a benchmark, it's going to be this number right here.
All right. So then, now my other homework is 26 or through 31.
Okay.
So let me
Don't
get
have that on that sheet that your mom sent. Just had through B. So can you verbalize those problems?
Yes, I could.
Okay.
Okay. So it says compare each pair of fractions in exercises 26 through 31 using benchmarks or another strategy that makes sense to you.
What's this? What's the first fraction?
And then it also says copy the fractions and insert the greater symbol
Okay.
or the less symbol
Okay.
or equal to
What
make
are
a true statement.
What are the 2 fractions?
7/10 and 5/8.
What's the best strategy to use to compare these 2 fractions, to figure out which is bigger?
1 sec, I'll just have them write down. 5/8. Probably, to compare them, let's see.
Let's convert to decimal.
Yeah.
What is 7/10 equal to?
7/10 equals, well, 7 goes into 10 one time.
No.
No.
Not dividing 7 into 10. You're dividing 10 into 7. But more importantly, what is 7/10? Isn't that 7/10 right there?
Yeah.
Okay. 5/8 is a little harder. 5/8, we got to divide 8 into 5.
Mm-hmm.
How many times does 8 go into 5? 0. How many times does 8 go into 50?
Mm-hmm. That goes into 50 6 times.
So already, no matter what the rest of the answer is, we know 7/10 is bigger, right?
Yeah.
Okay, let's go ahead and figure out what the rest of the answer is. Whoops,
Okay.
2, and that's a 5. So 5/8 is equal to 0.625.
Yeah.
So now it's easy to do the rest of the question, which is 7/10 is greater than 5/8.
Yeah. 1 second. Yeah.
What are the two fractions in 27?
7 times 5/8. 1 sec. Here, I'm just filling out the work for that problem. Then 5/8 equals 0.625. Yeah, so obviously 7/10 would be bigger.
Right.
Okay.
It's harder to tell when you look at the fractions, but once you convert both to decimal, then it's a piece of cake.
Yeah.
So that's going to be our strategy in all of these. What's 27?
Okay. 27 is 11/12 and 12/13.
You allowed to use your calculator here?
Well, Miss Foster, she doesn't like us using a calculator.
Okay, I can kind of understand why. Because if you
Yeah.
use your calculator, this becomes a piece of cake.
Mm-hmm.
In other words, whatever decimal you come up with, you compare the two, and there's no question.
Yeah.
Is there another way I can figure out which is bigger? Let me test you.
Yeah. Yeah.
What's
11/12.
No. What's bigger, 1/2 or 2/3?
2/3. 2/3.
How about 2/3 or 3/4?
Probably 3/4.
About 3/4 or 4/5?
4/5.
So now tell me which is bigger, 11/12 or 12/13?
12/13.
Notice what I did
Yeah.
to figure it out. I didn't convert it to decimal.
Mm-hmm.
I just knew that when you get bigger, when you increase the numerator and the denominator by 1 each, you get bigger each time. So 12/13 has to be bigger than 11/12 because we increase the numerator by 1 and we increase the denominator by 1.
Yeah.
If I said what was bigger, 211 over 212 or 315 over 316, which is bigger?
Well, you would 5/6 and 1/2.
No, this is 315, 316.
Oh, 15/16
Well,
and 11/12.
it's 315 316ths, and 211 divided by 212.
Yeah.
Again, this is bigger because I've increased the numerator and I've increased the denominator by exactly the same amount.
Yeah.
So the bigger numbers rule.
Okay. So
Now, what's going to be bigger, 11/12 or 9/10?
let's see. 9 times 10, 11, 11.
Using the same logic as
Yeah.
we just had.
Are they equal?
No? In other words, I added 2, so 11/12 is equal to 9 plus 2 divided by 10 plus 2.
Okay.
So since I added the same number to the numerator and the denominator, this has to be bigger, 11/12.
Yeah. Okay.
Because there's only one difference between the numerator and the denominator. There's only one difference between 9 and 10. But this is bigger. Numerator, bigger denominator, therefore this fraction is bigger. And if you use a calculator, you can prove it. 9/10 is equal to 0.9. What's 11 over 12? What's 11 over 12 equal to?
Let me do that on the calculator. What would you do for that?
11 divided by 12.
Yeah, that's what I thought. 0.916.
Notice that that's bigger than 0.900.
Yeah.
Okay, how about 28?
All right, 28. 12/15 and 12/14.
Okay. This one we don't need to convert it to decimal. The reason being we have the same numerators. This denominator is bigger than that denominator.
Making 12/15 greater than 12/14.
No, the other way around.
Oh.
Which is bigger, 6/7 or 6/8?
6/7.
Right. So if the numerators are the same, the one with the smaller denominator is the bigger number. So that
now I
makes
get it.
12/14 bigger than 12/15. So it's all about if you have the same denominator or numerator, the problem is really easy.
Yeah.
So what's 29?
Okay. 29 is 3/8 and 4/8.
Okay, here we have the same denominator. So which is bigger?
4/8.
Exactly.
No, 3/8.
No, 4/8.
Or 4/8,
In
yeah.
other words, when you have the same denominator and one numerator is bigger than the other, that's the bigger fraction. Notice 4/8 is 1/2. 3/8 is 0.375. 4/8 is 0.5. So this is always bigger. But what they're trying to teach you is that when you're comparing fractions and you have one of them the same, in other words, if the denominators are the same, whichever one has the bigger numerator is bigger.
All right.
If the numerators are the same,
Mm-hmm.
Whichever one has the smaller denominator is bigger. In other words, 11/12 is bigger than 11/13 because it has a smaller denominator and the same numerator.
Oh, yeah. Now I get it.
And if you ever forget, in other words, this is really not about memorizing. It's about being able to work it out. Okay? How do you work it out? How could, if you forgot everything I just told you, compare these two. Which is bigger?
Mm-hmm. 1/2.
Because it has the smaller denominator and
Mm-hmm.
the same numerator.
Yeah. All right.
Which is bigger between 2/5 and 3/5?
2/5.
No.
No. Oh, yeah. 3/5.
Because it has the same denominator, which means you go with the bigger numerator. So it's a different situation. In other words, it depends on what is the same. Is the numerator the same or the denominator the same? In this case here, it was the numerators that were the same. In this case here, it was the denominators that were the same.
Mm-hmm.
So if you always go back to a situation where you know the answer, you know that 3/5 is bigger than 2/5, and then you know that 1/2 is bigger than 1/3, then you can always figure out the rules that apply.
Yeah.
Even if I said, well, how about 111 divided by 221? How does that compare with 111 divided by 222? Which is bigger?
111 divided by 221.
Exactly.
Mm-hmm. Because it has a smaller denominator.
Exactly. That's what you need to remember.
Yeah.
Okay? You good to go?
Well, I have 2 more problems. So.
Okay. What are they?
Well, it's 30.
Okay.
And it is 3/5 and 4/6.
Now this is a little different. They don't have the same numerator or denominator.
Mm-hmm.
So one obvious way to solve this would be to convert to decimal, and then it's really easy to compare.
Yeah.
But let's think of another method. Well, in other words, my numerator is 1 bigger and my denominator is 1 bigger. So let's use a situation where we know. So here my numerator is 1 bigger and my denominator is 1 bigger. Which is the bigger?
I actually figured something out.
Okay.
Well, I know that 1/5 is greater than 1/6.
Okay.
So 3/5 is greater than 4/6.
No. Look at this situation right here. Which is bigger?
2/3.
Right. You can always figure this out, right?
Yeah.
That 2/3 is bigger than 1/2. Well, notice that 2 is exactly 1 bigger than 1, and 3 is exactly 1 bigger than 2. So whenever you take a fraction and you increase the numerator by a certain amount and the denominator by the same amount, you end up with a bigger fraction. So 4/6 has to be bigger than 3/5 because the numerator increased by 1 and the denominator increased by 1.
All right.
So what I'm trying to say here is that if you forget that rule, always go to a situation where you can figure it out. You know what that is right there. You know that 2/3 is bigger than 1/2. Therefore, when you take a fraction and you add a certain number to it, and you add the same number to the denominator, you end up with a fraction that's bigger.
All right.
What's your last one?
My last one is 31 and is 4/3 and 15/12.
3 numbers?
Well, 31 is the problem.
Ah,
Yeah, is the problem number.
we're comparing 4/3 with 15/12.
Yeah.
Okay. Notice this one, there's not a lot of relationships between the two.
No.
You can't say that the numerator increased by 1 or the denominator increased by, the denominator increased by 9, the numerator increased by 11.
Yeah.
So let's try to make these
It's
fractions.
an improper fraction.
Well, that's not the key. In order to compare the two, let's make them look similar. Let's give them both the same denominator or numerator. How would I give 4/3 the denominator of 12? What would I have to do to it?
Multiply by 3.
How about by
4 by
4?
3.
How about by that? In other words, I can multiply any fraction by 1 without changing its value.
Oh, okay.
That's equal to 16/12. Now you can compare 16/12 with 15/12 quite easily.
Oh, yeah.
Same denominator, bigger numerator, it's the bigger number.
Okay.
The key is to make its denominator the same so that you can compare them.
Mm-hmm.
And I did that by multiplying 4/3 by 4 divided by 4, which is the number 1.
Mm-hmm.
Remember, you can multiply any fraction by 1 without changing its value. So therefore, 16/12 has to be exactly the same as 4/3. And
Okay.
I can compare 16/12 with 15/12 really easily.
Yeah.
All right.
So 16/12 is greater.
Yeah.
Mm-hmm. Otherwise, 4/3
Well,
is
4/3
greater than
4/3 is greater than
15/12.
exactly. That's what you want to put.
Yeah.
4/3 is greater than
Yeah.
15/12. It's just that
All right.
4/3 is the same as 16/12.
Mm-hmm. Alrighty.
Okay. You good to go?
Let me just make sure. So I did 1 and then 26 and 31. Yep, I'm good.
Okie dokes.
Yeah, thank you so much.
You're welcome, Ethan. And anytime you need help, just call.
Yeah, sure, thank you.
All right. Talk to you next time.
Alright, bye, Mr. Cohen.